All of you welcome in our first period of MSC Part 1, Sem 1 Mathematics. We start the paper Numerical Analysis, which is the paper 5. There are 5 papers, you know. You have already sent the list of papers and the syllabus of MSC Sem 1. Now this is optional paper, Numerical Analysis. Myself, Dr. D.N. Warade. Now, first we start the method, bisection method. The papers, the unit wise, we start first the unit 1, methods of solutions of algebraic equations and system of nonlinear equations. In this, the first method we see bisection method. The method is given as, let we have to locate the root of the equation f of x equal to 0. We have to locate the root of the equation f of x equal to 0. This is the curve given by y equal to f of x in the figure. In the interval x0, x1, let f of x0 and f of x1 are of opposite signs. F of x0 and f of x1 are of opposite signs. If it is positive, then this is negative. If this is negative, then this is positive, like this. So that f of x0, f of x1 less than 0. If one of these x0, f of x0 and f of x1 is negative, then we have the product of these two is less than 0, which is the negative. Then the graph of the function crosses the x-axis between x0 and x1, like this. The graph of the curve crosses the x-axis between x0 and x1, so that there is at least one root in the interval x0 x1. There is at least one root in the open interval x0 x1. The desired root is approximately defined by the midpoint of this x0 and x1. That is, midpoint is given by formula x2 equal to x0 plus x1 divided by 2. If f of x2 equal to 0, then x2 is the desired root of the equation f of x equal to 0. And if f of x2 is not equal to 0, then the root may be between x0 and x2 or x2 and x1. Then the next approximation is given by x3. x3 equal to x0 plus x2 divided by 2. Here x2 is given by x0 plus x1 divided by 2. x3 equal to x0 plus x2 divided by 2. Provided that, what is condition? This is provided that f of x0 into f of x2 less than 0. The product of these two less than 0. Now out of these two, f of x0 and f of x2, one of these is less than 0, which is negative. Therefore, the product of two is less than 0, which is negative. Then the root may be found between x0 and x2, or by this formula x3 equal to x1 plus x2 divided by 2. Again, provided that the product of f of x0 and f of x2 is less than 0. Then the root lies between x1 and x2. And this procedure continue and so on. Therefore, we have at each step we find the desired root to the required accuracy. We continue the process up till we get the desired accuracy, or narrow the range to the half of the previous intervals, as in figure. The figure is given. This is the curve y equal to f of x. This origin, the points is x0, x3, x4, x2, and this is x1, x0, this is x1. Therefore, the first interval, open interval x0, x1 is given by this x0 and x1. This interval is the first interval x0, x1. The process of halving means the process of dividing the intervals is continued to determine a smaller and smaller interval within which the desired root lies. We continue the process so that we get the desired root which lies in the smaller and smaller interval. That is, we continue the process so that we get a smaller and smaller interval, and in that interval the root of the equation lies, the root of this equation lies between that interval. This is the figure of the bisection method. Now I have to see the examples of this bisection method to find the root of the equation. Now we take the particular problem on this method. That is, solve the equation for the root of the equation. Example: solve the equation x cube minus 9x plus 1 equal to 0 for the root between x equal to 2 and x equal to 4 by bisection method. Solution. Now we consider the given equation as f of x. Let f of x be the given equation, that is x cube minus 9x plus 1. Now I have to show that we have to find solve the equation for the root between x equal to 2 and x equal to 4. We find f of 2 and f of 4. Therefore, we find f of 2, that is, put x equal to 2 square minus 9 into 2 plus 1. Therefore, 4 minus 18 plus 1. Now this will get as minus 9, which is less than 0, which is negative, and f of 4 equal to 4 cube minus 9 into 4 plus 1. 4 cube 64 minus 36 plus 1. Now this will get as minus 29. Now plus 29, not minus. This is positive value. Therefore, if we take the product of 2, we get a negative value, because one of the number is negative. This is positive, this is negative. Therefore, product of these two is negative. Therefore, f of 2 into f of 4, that is minus 9 into 29. The product is less than 0. And the root lies between 2 and 4. And hence the root lies between 2 and 4. And therefore, the root lies between 2 and 4. Let x0 equal to, therefore let x0 equal to 2 and x1 equal to 4. Therefore I define x2. Therefore we define x2 equal to x0 plus x1 divided by 2, that is 2 plus 4 divided by 2, 6 by 2 equal to 3. As the first approximation, root of the equation f of x equal to 0. Now here f of 3 equal to this value x2 equal to 3. Therefore, we find f of 3 equal to 3 to the power 3 minus 9 into 3 plus 1. 27 minus 27 plus 1 equal to, we get the value 1. Also f of 2 into f of 3 and f of 2 into f of 3. F of 2 equal to minus 9 into 1, which is we have negative less than 0. Which is negative less than 0. Therefore, the root lies between 2 and 3. Therefore, say that the root lies between these 2 and 3. Implies the root lies between 2 and 3. Again, we define x3 like this x2. Define x3 by like this midpoint. x3 equal to, we get x0 plus x2 divided by 2. x0 plus x2 divided by 2, that is 2 plus 3 divided by 2, 5 by 2, that is 2.5. And I know that f of x3 equal to, and f of x3 equal to f of 2.5 equal to, put here in the equation of f of x, put x equal to 2.5, 2.5 cube minus 9 into 2.5 plus 1. Now we will get this value as negative. Once we will get the value negative, f of x3 minus 5.8 minus 5.875, which is nothing but negative. Less than 0. Now this one of the value is negative, therefore we get the product of f of 2.5 and f of x3. Therefore f of 2.5 into f of 3 we get negative. Because f of 3 is 1 positive and f of x3 is negative, therefore the product we get less than 0, which is negative. Therefore we define x4 as the midpoint. Therefore we define x4 as a midpoint as x4 equal to x2 plus x3 divided by 2. Now x2 equal to 3, x3 equal to 2.5. 2.5 plus 3 divided by 2, which is 5.5 divided by 2, which will get 2.75. Similarly, we continue the process and we obtain x5 and x6. Similarly, we continue the process and obtain x5 and x6 as x5 equal to we get 2.875 and x6 equal to 2.9375. And the process will be continued until the root obtained to be desired accuracy. Now we take the result or combine the results in the table. The results are expressed as in the table. Take the value of n, then xn, f of xn, first n equal to 2, 3, 4, 5 and 6. So xn equal to, we have obtained 3, 2.5, 2.75, then 2.875, next value 2.9375, and f of xn, for first we have seen it is 1.0 minus 5.875, third minus 2.9, 531, next minus 1.11, 13, next minus 0.0901. Which is the solution of the given equation x cube minus 9x plus 1 equal to 0. This complete the example. Now stop for this period. It is sufficient for today.